Okay, let's get started. So today we were going to talk about Istio security and Istio certificate management. My name is Lei Tang, and my teammate is Yonggang Liu.
Oliver.
Yeah, we both from Google Istio team. So nowadays, a company may have tons of services. And these services, they typically depend on each other. They will call each other. And the service owners need to manage these services. For example, to manage their security, manage their traffic, collect telemetry data, and display the telemetry data, quota control. There are a lot of management to do. So when the number of services increase, it becomes more and more complicated to manage these services. And sometimes it becomes very messy, and if there is a configuration error, it may cause service disruption or security loophole. So Google invented Istio to help users to manage their microservices. And now I will talk about the high-level view of Istio. So at high level, Istio consists of control plane and data plane. So control plane manages the policies, and the data plane actually enforces the services. There are three components in the control plane. One is pilot. So pilot gets the policy from the operator and interpret the policies and translate the policies into Envoy config. So Envoy is the data plane. So these configurations are pushed to the Envoy, and the Envoy actually enforces these policies. So the second component is Citadel. Citadel is the entity that manages Istio certificates. And the third entity is Mixer. So Mixer will do the quota control, and it will report the telemetry data, collect the telemetry data. So now I will use an example of a single HTTP request to see the life of this request. First, it will reach the internet and then eventually reach the data plane. So after the data plane, all these policies are enforced. For example, security, traffic management. You can deploy your service to different versions, route your service to different versions, and collect the telemetry data and report the telemetry data. And also you can do quota control and do the service policy control. So security is critical to any microservice, and in a service mesh, there are all kinds of security threats. For example, the attacker may try to eavesdrop the traffic. The attacker may try to access a service that is unauthorized to. And inside of the service mesh, there are also all kinds of attacks. For example, a service may try to access another service that is not authorized to. So Istio security is based on decades of Google production security experiences. In particular, beyond the Corp and application layer transport security. So in traditional network parametered security model, if the access is from a IP address within the VPN or within the firewall, then the access is granted. So this access model doesn't recognize the fact that the security threats may also come in from within the a service mesh. So beyond the Corp abandoned this network perimeter-based security model. Instead, beyond the Corp enforce security based on identities, connection state, request attributes, based on a comprehensive list of the context information to enforce the security. Application layer transport security issues the identity to every workload in the service mesh and encrypt the traffic between the two workloads and also authenticate the requests. Istio provides a platform to help users to secure their microservice as Google do. So, same as the Beyond the Corp, Istio has no trust to the network. And whether access is granted or denied is based on the context. So the context may include identities, connection state, for example, whether the connection is encrypted or not, and request attributes. For example, where this request is from, where it's, the peer link is, where the peer service is, who is the caller. So based on a comprehensive list of context information, Istio is secure by default. So the services owners, they don't need to change a line of their code. The service enforcement is transparent to the service owner. So the service owner can focus on developing their business logic without spending time manage their services. So same as the application layer transport security, Istio encrypts the traffic within the service mesh. So every access is encrypted and authenticated, authorized based on the context information. So Istio enforces the context-aware access control. So the context can be the identity, can be the location, can be the channel state. And this context information, they can be encoded in JSON Web Token. So when the request comes, the request will be accompanied by a JSON Web Token. It can also be obtained, this context information can also be obtained by the data plane, by Envoy. At the same time, the identity can be also represented by the certificate. Istio follows the SPIFFE standard for the identity in the certificate. So with this identity scheme, the service count of a workload is represented by the namespace and the service account name. So here I will give you an example of how Istio conducts context-aware access. So the operator of the service mesh defines the policies. The security policies are eventually transmitted to pilot. And the pilot interprets these policies and converts them to the data plane configurations and distributed to Envoy. So when a request comes, so the request may have the context information, such as job, certificate, and other context information obtained by the data plane. The data plane has authentication filter. Authentication filter will authenticate the context information and decide whether this is valid or not. If these attributes, this context information have been authenticated, then it's passed to the authorization filter. So the authorization filter will, based on the authorization policy, to decide whether to reject the access or grant the access. After this policy enforcement, the request is forwarded to the backend service. So the backend service is, all this policy enforcement is transparent to the backend service, and the backend service will process the request and send back the response. Next, I will do a demo of Istio context-aware access control. So in this demo, whether the access is granted or denied is based on two context information. One is whether the end user belongs to a specific group. So if the end user is not in this group, then access will be denied. The second context information is whether this connection is encrypted or not. It's basically protected by mutual TLS authentication. So here, the operator can even define more context information to further control the calling path. For example, if this sensitive service is billing service, the billing service may only allow the account service to call itself. So by further control the calling path, the benefit is even if there is the attacker has a valid job, a valid credential, the attacker still will be unable to access the sensitive service because the attacker simply doesn't have this multiple context information to match the policy. The attacker must be calling the billing service from account service, but account service is not compromised. Only the attacker only have a valid job, so the access will still be protected. But here, for simplicity, I will only use two context information to protect this service. So here I will give you the detailed policies for this context-aware access control. So Istio, for a service to protect itself, it doesn't need to change the code. It basically needs to define the policy and deploy the policy. And the policy is simple to read. So for the demo for this demo, the authorization policy will restrict the end user to be from group 1 here. Let me use a pointer. Here, the group 1. So this is basically restrict the end user. And here in the demo, we also define the authentication policy. So to encrypt the channel, we deploy a mutual TLS policy as the authentication policy. At the same time, we require the end user to present a valid job in order to access the policy. Okay, now I'm going to show you the demo. Okay, so first of all, we will deploy the policy. So this policy includes authentication policy, authorization policy, and also start the services. Next, we will use a job to test our access control. So this job, it doesn't have the valid group information. So doesn't have valid group information, the access will be denied. So here the 403 code is because the access is denied. Next, we will use a valid jot, contains the valid group information. Let's view the content of this jot in the website. Here you see this group 1 and 2. So this is a valid jot. And with this valid jot, the access is granted. This 200 code is returned. Next, we will show that even with a valid jot, but without an encrypted channel, the access is denied here. So this shows a couple of things. So first is with a valid context information. This valid context information are two information. One is the channel is protected by mutual TLS. Another is this is from a valid group. Then the access is granted. But if the attacker happen to get the valid jot, but it doesn't have the another context information, which is the encrypted channel, then it fails. So this is the failure here. The failure is this part. So let me go back. Next, I will hand over to my teammate for the certificate management in Istio.
Hello, everyone. So I'll bring something new to you guys. Probably every one of you read about their docs about our security story. And here, what I present is our next step. This architecture will be available in from Istio 1.2. So what we do here is we are going to introduce a new node agent. It is per Kubernetes node. And what it does is it exposes the SDS API, which is Envoy Secret Discovery Service API. It's a new API. What it does is it delivers the key and certificate to the Envoy dynamically. So when your pod is deployed with an Envoy sidecar, the Envoy is able to directly call into that SDS API on Node Agent. And the Node Agent forwards that that request to the Citadel along with the Kubernetes jot. In this way, the Citadel is able to directly authenticate the workload's service account, right, from the Kubernetes jot. And then after the authentication, it will check if this service account is allowed to grab a certificate. If so, it will issue a certificate to the node agent, and node agent will forward that certificate to the Envoy. Notice that the SDS API between this pod and the node agent is through the UDS, so it's secure. What the node agent solves are two problems, right? The first problem is, if you know previously our security architecture, the Citadel is hooked up with the API server, and it watches the service account creation and deletion. And then, based on those operations, it will generate the certificates and then write into the secret. The workload pod will dynamically watch that certificate. It's mounted in a local file, and if it's changed, it will restart the pod. Restart the Envoy, and then there's a restart delay there, even though it's a hot restart. And the second problem it solves is it decouples the Citadel. So the node agent is able to implement more adapters to be able to call out to other CAs. It could be Acme, it could be your own CA. So next slide, I'm going to talk about the integration with the external CAs, right? we propose 3 approaches here, depending on how your system is designed, what you want. The first one is the signing key injection. This already exists in our current system. What it does is it allows the user needs to manually grab the key insert from their own CA and then put that key insert into the system by the secret volume mount. And then the CA will see, okay, there's a new signing key insert, and they will use it. It's manual, unless you write a script. And second one is Citadel-integration. It allows the Citadel to dynamically call out to your API. It could be Acme. It could be your own CA, as long as you write an adapter on Citadel. The third one is Nodeagent-integration. It's able to get rid of the Citadel. If your system doesn't want to use Citadel, it can directly hook up with your own CA. So next slide, I'm going to talk about each of them, right? So I still have some time. The first approach is signing key injection. I hope this graph is pretty straightforward. The person there, he needs to go to the external CA and then grab the key and insert from that CA and then insert into the system through the secret volume mount. Citadel will issue the certificate through the existing way using the node agent and to the pods. This is manual, and that's why we propose approach 2. Through this approach, the Citadel will have an adapter that talks to the external CA. Could be Vault, right? We are talking about Vault here. So later, we'll use this same architecture for Vault integration. It could be less encrypt, could be your own CA. And the good thing is, the external CA doesn't need to recognize the internal identities through the authentication mechanism because Citadel authenticates it. And Citadel is delegated to request all the certificates requested by in the cluster. It just represents all the workloads and asks for their certificate to their external CA. But if you don't want to have that mechanism, you can use the node agent directly to talk to the external CA. The difference between this and that is not only there's no Citadel in this architecture, but also your external CA needs to directly authenticate the Kubernetes jot. So the Kubernetes jot is forwarded through the node agent to your external CA. The external CA handles the authentication directly, right? And this is much simpler architecture, and once our 1.2 is available, we will support this approach as well. So I will hand back to Lei.
Okay. You can keep this. Okay. Thank Oliver to introduce the Istio certificate management architectures and different designs. So here I will actually use Vault as a prototype to demo how Istio CA can be integrated with external CA to issue certificates inside the Istio. And this work will allow an organization to plug in their own CA. So currently, like Oliver has introduced, Istio uses the Citadel to manage the certificates. With the pluggable CA, then an organization, they may use their own CA to issue the identity certificates inside the Istio. We think this will provide a lot of use cases for different companies. Okay, next, I will present the detailed working flow for integrate Istio CA with Vault. So actually, go back to a little bit. So Vault is an open source tool that is widely used by microservices to manage the secrets. Vault supports use HSM, hardware security module, to store the private keys and manage the private key security. And let's go back to the flow. So the first step is when the envoy of a workload wants to get a certificate, it sends a secret discovery service request plus its own identity to the node agent. And the node agent will generate a certificate signing request and forward the service account of the Envoy to Citadel. So the service account here is a Kubernetes service account. It's a JOT. And the Citadel will do authentication and authorization for this service account, for this JOT, by contacting the Kubernetes API server. So the API server issues the JOT, so it will be able to authenticate the JOT. After the authentication, the Citadel will do an authorization check. So this authorization check will check the identity from the pod's Envoy, matches the identity in the certificate signing request. So this will prevent an attacker to request an identity that doesn't even belong to to itself. So after the authentication and authorization at Citadel, Citadel will forward the certificate signing request and its own identity to Vault. So Vault will authenticate and authorize based on the service account of Citadel. So after the authentication and authorization pass, Vault will sign the certificate request and return the signed certificate back to the requester. So this is the flow. Next, I will do a demo of Istio CA Vault integration. So in this demo, we will go through the whole flow from the requester sending a request for certificate to the request being returned to the requester. So first, we will create a deployment to request for the certificate. Next, we will dump the logs. After the certificate is requested, we will get the certificate. We dump the certificate printed in the logs. So we will dump the log here. So this is the signed certificate. And we will use OpenSSL to dump the certificate to say this is a certificate issued by Vault. Okay. So from here, we can see the certificate issuer is Vault that is waiting on the 8200 port. And the identity in the certificate is the example pod we created for this demo. That concludes our presentation, and we are now going to take the questions.
All right, thank you, Lei.
Yeah.
So this is a Q&A part, and we welcome you to take the survey, and then we have the rewards for you. Please don't rush. So if anyone has questions, please go ahead.
With the great thing with less encrypt, like the plugin that will go into
Can you
Citadel.
start again? Okay, start.
So when integrated with Let's Encrypt, the plugin that we're gonna tap into Citadel, it's still to be built.
Yes.
Okay. So like the next version of Istio is going to release like the node
Nodeagent.
the Nodeagent and the new version of Citadel, and then we're gonna build like all the integrations and the. Okay, awesome.
Right. We are planning to write the adapters. It's been a long plan. But we are planning to write the Acme adapter to interact with the Let's Encrypt. By the way, we do have for the ingress gateway, we do have a cert manager. If you know about it, it can already interact with Let's Encrypt.
Yeah. And I was curious, like the certificates now that. Like bringing your own certificate authority. This means that will be only at the edge, like on the ingress controller, or you can use the certificates within, like replacing the MTLS or something like that with your own signed certificates.
Yeah. So for the mutual TLS inside the cluster, we rely on the internal certificates, right? It's issued by the Citadel or your own CA if it integrates with Citadel. For the edge certificates, you could use the Citadel to sign that as well, but normally people don't do that. Yeah.
Thanks.
No problem. Go ahead.
So one question. So when managing multi-cloud with Istio,
right?
So is there a way to so if I'm in the same cluster, not to use the certificates for, and then like when I'm communicating cross-cloud, then I need to use the certificate. Like, is this feature like?
Yeah, multi-cluster is what we are working on, right? And currently we do have a solution for Istio 1.0, which is to, through the first approach that I proposed, you offline generate a key insert, and then put that key insert, that signing key insert into multiple CAs. Each Citadel, right? Each Citadel is in one cluster, so that they are using the same signing keys. They are able to connect to each other automatically. But that's not sufficient, right? We are going to like move forward for more, for better solutions. Yeah. Go ahead. Oh. Yeah. By the way, so we are planning to propose multi-layer PKI to the open source part of Istio. So. Basically, what it does is you will have a root CA that is running, could be running in a VM or in a cluster, and then you have intermediate CAs that directly talk to the root CA. And then your intermediate CAs are able to like issue certificates for their workloads. So in that way, you will have only one root CA, and then you will have multiple intermediate CAs. Each CA is covering one cluster, right? So, is there any more questions? If no more questions, we can get some rewards. All right. Thank you.
Thank you.